Hi everyone, welcome back. Imagine if you could tackle two major global issues with one chemical reaction. That's what garbage gasification might be able to do. This chemical process aims to reduce waste in landfills and reduce greenhouse gases by providing a renewable energy source. Sound too good to be true? Well, maybe it is. Let's investigate Canada's waste generation and how a process called garbage gasification might be able to address some issues. We'll explore this process some more by examining the advantages and limitations of this chemical process. Let's get started. On average, Canadians each generate 720 kilograms of municipal solid waste per year, which is just a fancy way of referring to the everyday waste generated by households and local operations. 720 kilograms is a particularly scary number when you compare that to the global average of 480 kilograms. Add to this, approximately 60% of Canada's municipal solid waste is landfilled, meaning it's buried in the earth. But where else is it going to go? Well, Sweden has a pretty nifty idea. They only send 1% of their municipal solid waste to landfill. The rest gets converted into energy. Garbage gasification plays a major role in this. Garbage gasification is a process that converts garbage into gases such as carbon monoxide, hydrogen, and carbon dioxide. These gases combine to make a product called synthesis gas, or syngas for short, which is similar to natural gas and can generate electricity. The most useful garbage for this process is carbon-rich materials, such as plant materials, animal waste, or everyday items like product packaging, furniture, clothing, bottles, food scraps, newspapers, appliances, and batteries. That's a pretty extensive list. So how do we turn garbage into gas and then into electricity? Basically, garbage gasification works by reacting the physical materials at high temperatures with a controlled amount of oxygen and steam. Let's break down the steps involved. First, the waste material is dried to remove moisture, usually done by heating the waste to around 100 degrees Celsius. Next, the dried waste is heated to higher temperatures, between 500 and 800 degrees Celsius, without oxygen. The waste then breaks down into a mixture of a solid, liquid, and gas. The solid residue is called char, a mixture of carbon and ash. The liquid is called tar, a type of hydrocarbon, meaning it contains hydrogen and carbon atoms. And finally, a gas, the exact composition of which can vary depending on the type of waste and the composition of the air that's inside the gas chamber. Next, the char is converted into a mixture of carbon monoxide and carbon dioxide. This is done by partially burning the char with a controlled amount of oxygen. Without oxygen, an incomplete combustion reaction occurs to produce carbon monoxide. Carbon dioxide is formed by introducing a small amount of oxygen. At the end of this stage, we are left with a carbon-dense mixture of gases, primarily carbon monoxide and hydrogen, with smaller amounts of carbon dioxide and other gases, otherwise known as syngas. Finally, the syngas is cleaned to remove impurities, such as sulfur and particulates, before use. Through gasification, we have turned our solid waste materials into gaseous ones. Now you may be wondering, what do we do with this gas? Well, syngas is a combustible fuel, meaning it can be used in power plants to generate electricity. Put simply, all that garbage in your bin could be used to power your home. Garbage gasification sounds pretty great, right? Let's look at some of its advantages, including social and environmental. First, because the syngas can generate electricity, it provides a renewable energy source and reduces our dependence on fossil fuels, which unfortunately will eventually run out. Humans aren't going to stop producing waste anytime soon, so this is a long-term solution to our energy crisis. Next, gasification can handle a wide range of waste materials, including hazardous and non-recyclable waste. So gasification significantly reduces the volume of waste that would otherwise end up in landfills. By using the waste instead of putting it in landfills, we can conserve land space, improve waste management strategies, and reduce the environmental impact of waste disposal. Landfills are the third largest source of methane emissions in Canada. In 2019, they accounted for 20% of the country's total methane emissions. So, if we could reduce the volume of landfills in the future, we could have a big impact on greenhouse gas emissions. Finally, let's talk money. The process of gasification can create jobs, which supports the local economy. Not to mention, with the right equipment and technology, gasification has the potential to become a profitable business venture. Gasification produces enough energy that a factory can power its processes, saving on operating costs, and still have enough to sell to the public or other businesses. So, garbage gasification can reduce our reliance on fossil fuels, reduce the volume of waste ending up in landfills, and could potentially be a great business opportunity. So, why isn't more of it happening? Well, there are also challenges and limitations to face. Firstly, there's the initial cost of setting up gasification plants. Building a factory near enough to local communities so that local garbage doesn't have to travel far would be a significant investment if governments wanted to make this a large-scale operation. So that's a real barrier for governments, organizations, or companies wanting to move towards sustainability. Secondly, releasing toxic substances during gasification can pose health and environmental risks. The chemical reaction between the char and low oxygen environment produces particulate matter and ash as byproducts, which can contaminate the air. That's a pretty significant limitation if the aim is to reduce environmental impacts. Finally, syngas, while sounding like a super green form of energy so far, is a way less efficient energy source method compared to similar products like natural gas, a non-renewable energy source. To put it in perspective, it's about half as efficient most of the time, which means it takes double the amount of syngas to do the same job as natural gas. But this can change depending on the quality of syngas and natural gas you're comparing. So, while garbage gasification has the potential to address some social and environmental needs and problems, it's expensive to set up, less efficient than natural gas, and still releases harmful products to the environment. Alright, let's wrap up there with some questions. First, how does garbage gasification convert waste to a gas and then to electricity? Waste is dried out and burned at high temperatures to produce char. Oxygen is slowly introduced to the chamber and combustion occurs, producing a gaseous mixture of mostly hydrogen and carbon monoxide with some carbon dioxide and other gases present. This mixture is called syngas and can be used to generate electricity. Next, what are some advantages and limitations of garbage gasification? Some advantages are that it targets major global issues such as waste heading to landfills and provides a renewable energy source. However, high start-off costs and low efficiency stand in the way of large companies and governments adopting this process. See you next time!